All right. With what said, let's talk about what this program actually offers you. This entire experience is built on four key pillars designed to help you succeed. First, study groups. That's what we are doing right now. We will have weekly live sessions led by experts, developers to go through the material and answer your questions on demand. You will also get free access to online courses and labs from Google Cloud. These are all hands-on and just like real-life projects. At the end, I will share a link to our Discord channel where I will share all necessary links as well. Hands-on labs. This is where your practice. You'll get to use Google Cloud tools and earn skill badges, which are like mini credentials you can share, and community. So it's your part of community. This is a place to connect with other people, get help, and share your own experience. By combining these four things, we are confident you all have everything you need to prepare for the certification. Okay, I'm excited to guide you today's throughout session. We will be focusing on machine learning fundamentals, sample questions, homework, and of course, you can ask questions at any time by submitting them in chat. I'll collect all questions and answer them at the end. Let's get started. This week is all about understanding the bedrock of many AI systems and learning how to effectively communicate with them. So let's dive in. Okay, before we go too far, let's quickly clear up two common terms: artificial intelligence and machine learning. People use them a lot, sometimes for the same things, but they are a little different. Artificial intelligence, or AI, is a big idea. Think of it as a huge umbrella that covers anything where a computer acts smart, like a human. Things like self-driving cars or robots are all examples of AI. Machine learning, or ML, is a part of AI. It's a specific way for a computer to learn without being told every single step. Instead of giving the computer strict rules, we give it data and let it find its own patterns. You can see in the middle diagram that AI is a big circle and machine learning is a smaller circle inside it. Machine learning itself has different types like supervised learning and unsupervised learning. You might also hear the term deep learning. That's more advanced type of machine learning that uses something called neural networks to learn in a deeper way. Don't worry too much about the details right now. We will dive much deeper into neural network and deep learning later in this course. Namita, yes, how? Hi, happy to see you. I'll answering and greeting all of you at the end of the session, okay? So let's continue. Building on what we just discussed, let's look at the two main types of machine learning models: supervised and unsupervised learning. The key difference is how the deal is labeled. On the left, we have supervised learning. Think of this like having a teacher. We give the model labeled data, meaning we have already given it the correct answer. And the goal is to learn from these examples to make a prediction on new data. For example, if you want a computer to tell the difference between a dog and a cat, you would give it a bunch of pictures that you have already labeled dog or cat. The computer learns from these examples and then it can identify new, unlabeled pictures on its own. On the right side, we have unsupervised learning. This is like letting the computer learn on its own without a teacher. We give it unlabeled data with no correct answer. The computer's job is to find hidden patterns and group the data for us. For example, if you have a lot of pictures of different dog breeds, but you don't know what they are, you could use unsupervised learning. The computer would look at all the picture and group them together based on their features, like size, color, or shape, without telling uh, what those groups should be. And let's take a closer look at supervised learning. It's broken down into two main types of problems. First, on the left, we have classification. This is when we want to predict a category or a label. A simple example is determine if a picture is a cat or a dog. The answer is a category. You use model like logistic regression for this type of problem. And second, on the right, we have regression. This is when we want to predict a number. For example, we might want to forecast the sales or a product next month based on its sales history. The answer here is a specific number. For these problems, we often use models like linear regression. So remember, classification is about predicting a category, and regression is about predicting a number. There are three major types of unsupervised learning. The first is clustering, which groups data points with similar characteristics into clusters. For example, this is used to determine customer segments based on demographic. You would use models like k-means clustering to solve these problems. The second type is association, which identifies underlying relationship. Think of correlation between two products that a grocery store might use to place them closer together. This uses techniques like association rule learning. And the third type is dimensionality reduction. This is a way to reduce the number of features in a data set to make a model more efficient. A good example is combining customer characteristics like age and car type to create a simplified rule. For example, for an insurance quote. For this, you would use techniques like principal component analysis. You may already know about various neural networks, such as deep neural networks or DNN, convolutional neural networks or CNN, recurrent neural networks or RNN, and more recently, large language models, our lovely LLMs. These networks are used to solve different problems. All of these models stem from the most basic artificial neural networks, or ANN. ANNs are also referred to as neural networks or shallow neural networks. And let's now focus on this ANN, which stands for Artificial Neural Network. This slide shows how a neural network learns. As you can see, an ANN has three main layers: an input layer, a hidden layer, and an output layer. Each one of these circles you see is a neuron. And the lines connecting them are how information is passed throughout the network. This is similar to how a human brain works. For example, imagine you feed the network a bunch of article titles. The network can then learn to figure out which media outlet or platform the article belongs to, like GitHub, New York Times, TechCrunch. So, how does an ANN learn from examples like this and then make predictions? Let's take a closer look at how it works. Let's do a simple walkthrough with this diagram. Here we have a very basic neural network. It has just two input neurons and a single hidden neuron and one output neuron. The lines you see connecting these neurons are all associated with something called a weight. Exactly these weights are the most important part of the learning process. They hold the information that the neural network learns during training. The goal of the network is exactly to find the best possible value for these weights. The first step in the neural network is to calculate the weighted sum. This is done by multiplying each input value, like x sub 1 and x sub 2, by its corresponding weight, and we then sum these products. As you can see, the formula normally includes a bias component, which we will call b sub I. This bias is important because it allows the model to shift the activation function. We will talk more about it later, which helps it learn more effectively. For this basic walkthrough, we can still focus on the core idea of the weighted sum. The second step is to apply an activation function to the weighted sum we just calculated. So you can see here as a symbol f of sigma. We will pause for a moment on the details of what an activation function is and why we need it, but we will come back to that shortly. It's true. So, finally, in the third step, the weighted sum is calculated for the output layer. This process assumes we have multiple neurons in the hidden layer, which would all feed into the output layer here. The fourth step is to apply another activation function to the weighted sum in the output layer. It's important to note that this function can be different from the one we use in the hidden layer. The final result of this process is the predicted output, which we represent with the symbol y hat. This symbol represents the predicted result from our model, while the symbol y on its own represents the actual result. Now, let's go back to our previous question and get into the details of activation function. So, what exactly does an activation function do? Simply put, an activation function is used to prevent linearity or to add non-linearity to our model. This is an extremely important step, but what does it actually mean? Let's take a look. This slide shows what happens when we don't have an activation function. Without it, our predicted result y hat will always be a linear function of our inputs, no matter how many layers we add. To see why, let's look at the calculation for the hidden layer. The value of this layer, which we call h, is just the total of our inputs, x sub 1 and x sub 2. As you can see, the final output y hat is also just a simple linear equation, as this is the key problem we need to solve. This slide shows what happens inside our neural network when we don't use an activation function. First, let's look at the hidden layer. The value of this layer, which we call H, is calculated as a simple weighted sum of the inputs. There's no activation function to add any complexity to this calculation. Then we take the value of H and multiply it by another weight W sub 3 to get our final output Y hat. The math of the right side of the slide shows what happens when you combine these two steps. Even though our signal traveled throughout a hidden layer, the final output is still just a simple, single linear equation. Because of this, the entire hidden layer is essentially useless. Its purpose is to add complexity so the neural can learn. But without an activation function, it completely fails to do so. This is a crucial problem that activation functions are designed to solve. This slide shows us the fundamental problem that activation functions are designed to solve. You can think of the hidden layer as a special kind of bridge. The purpose of this bridge is to make the relationship between our input and output more complex so our model can learn. However, if our output is just a linear function of our input, then this bridge is just a straight line. It doesn't actually add any complexity, and the entire hidden layer becomes completely useless. This is exactly why we must use activation function. They are what convert a linear network into a non-linear one, giving it the power to solve much more difficult and comprehensive problems. So, what are some of the most widely used activation functions? First, there's the rectified linear unit, or ReLU for short. This function is simple. It turns any negative input value to 0, but keeps the original value if it's possible. Next, you can use the sigmoid function. This one turns any input into a value that falls between 0 and 1. And finally, we have the hyperbolic tangent, or tang. This is like a shifted version of sigmoid, as it generates a value between -1 and +1.
Welcome to this Steeples Root series where...
So, another interesting and very important activation function is called softmax. As you can see, this slide shows the key difference between the sigmoid function on the left and softmax on the right. Sigmoid is typically used for binary classification, where the model has to choose between two options, like deciding if an email is spam or not. Softmax, on the other hand, is used for multi-class classification. This is for when the model needs to choose between multiple categories, such as classifying an article source as GitHub, New York Times, or TechCrunch. To understand it, let's look at the sigmoid function again on the left side of the slide. We know it generates a value between 0 and 1 and is perfect for binary classification, like deciding if an email is spam or not spam. But what if you have multiple categories for choose from, like GitHub, New York Times, and TechCrunch? For this, you must use softmax. It's a specific activation function used for multi-class classification, which is what you see on the right side of the slide. The key things to remember about softmax is that its output is a probability distribution. This means that the function maps each output to a value between 0 and 1. And importantly, all of the outputs for a given prediction will add up to exactly 1. The formula you see here on the slide, f sub I of x vector, is how that calculation is done, turning out our outputs into a set of probabilities. To summarize what we've learned and skipping all the complex math, you can simply conclude that softmax and sigmoid are used for different types of problems. As you can see on the slide, softmax is used for multi-class classification, like classifying an article title into one of many categories. In contrast, sigmoid is used for binary class classification, which is when you only have two options, like in a mail, spam detection, spam or non-spam. It's also important to note that you don't need to use the same activation function for every layer in your network. As you can see on this example on the slide, you might use RLU for your hidden layers and a different function like softmax for your output layer. Now, that you understand what an activation function is and how we get a predicted output, the next logical question is, how do we know if our result is actually correct or not? To answer that question, we use an assessment called a loss function or a cost function. As you can see on the slide, this function measures the difference between our predicted result, y hat, and the actual result, y. The difference between these two terms is that a loss function calculates the error for a single training instance, while a cost function measures the total error from the entire training set. Therefore, in step 5, we calculate the cost function. The whole point of this is to minimize the difference between our predicted and actual results. If the difference is large, the neural network knows that it did not make a good prediction. It then must go back and learn more by adjusting its parameters, which are the weights and biases we talked about earlier. There are many different cost functions used in practice. For regression problems, a very common one is the mean squared error, or MSE. This is typically used in linear regression models. As you can see, MSE equals the average of the sum of the squared differences between the predicted value, y hat, and the actual value, y. For classification problems, we typically use a different function called cross entropy. This is used to measure the difference between the predicted and actual probability distribution in logistic regression models. You can think of cross entropy as the difference in probability between our model and the true state. As we just discussed, if the difference between our predicted and actual result is significant, we must go back and adjust our weights and biases to minimize that cost function. This crucial sixth step is called back propagation. The big challenge now is how to actually adjust those weights in the right way. The solution is a little complex, but it's definitely one of the most interesting parts of neural network. The core idea here is to take our cost function and turn them into a search strategy. This means we use the cost function to measure our model's error and then use that information to find the best possible weights and biases. We are essentially searching for the perfect combination of parameters that gives us the lowest possible cost. This is the foundation of how our models learns. This is where gradient descent comes in. Think of this surface as our cost function, where the height represents our model's error. The goal is to get to the very bottom, where the error is at its lowest. Gradient descent is a process of finding the direction of the steepest slope in this surface. The model then takes a small step in that direction. As you can see by the part of arrows, it repeatedly finds the steepest slope and takes a step, slowly walking down the surface until it reaches the bottom. To successfully find the bottom of our cost function, we can break that problem down into two important questions. The first, as you see on this slide, is which direction should you take? The answer to which direction we should take involves using the derivative. Let's look at this slide. Say you start on the top left. When you calculate the derivative of the cost function at that point, you find that its value is negative. This means the slope is negative, and to get to the bottom, you must move down and to the right. And now let's say you are on the right side of the curve. When you calculate the derivative here and the value is positive, this tells you that the slope is positive and you must now move down and to the left to get to the bottom. So you calculate the derivative on the cost function every time to decide which direction to take. Repeat this process according to gradient descent and you will eventually reach the regional bottom. Now that we have answered the first question of which direction to take, the second depends on the learning rate, which determines step size or learning rate is hyperparameter that is set before training. If the step size is too small, your training might take too long. But if the step size is too large, you might bounce from wall to wall or even bounce out of the curve entirely without converging. When step size is just right, you are set. And the seventh and last step is iteration. One complete path of the training process from step 1 to step 6 is called an epoch. You can set the number of epochs as a hyperparameter in training. Weights or parameters are adjusted until the cost function reaches its optimum. You can tell that the cost function has reached its optimum when the values stop decreasing, even after many iterations. This is how a neural network learns. It iterates the learning by continuously adjusting weights to improve behavior until it reaches the best result. This is similar to human learning lessons from the past. Learning about neural networks can be cited but also overwhelming with a large number of new terms. So let's take a moment to review them. In a neural network, weights and biases are parameters which are learned by the machine during training. You have no control of the parameters except to set the initial values. The number of layers and neurons activation function, learning rates, and epochs are hyperparameters, which are decided by a human before training. The hyperparameters determine how machine learns. For example, the learning rate decides how fast a machine learns, and the number of epochs defines how many times the learning iterates. Normally, data scientists choose the hyperparameters and experiment with them to find the optimal combination. However, if you use tools like AutoML, it automatically selects the hyperparameters for you and saves you plenty of experiment time. Root means square error, RMSE. So RMSE is the square root of the average square difference between the target and predicted values. RMSE is more sensitive to outliers than MAE. So if you are concerned about large errors, then a root mean square error can be a more useful method to evaluate. Similar to MAE, a smaller value indicates a higher quality model. 0 represents a perfect predictor. A confusion matrix is a specific performance measurement for machine learning classification problems. It's a table with combination of predicted and actual values. To keep things simple, we assume the output includes only two classes. Let's explore an example. The first is a true positive combination, which can be interpreted as the model predicted positive, and that's true. So, the model predicted that this is an image of a cat, and it actually is. The opposite of that is a true negative combination, which can be interpreted as the model predicted negative, and that's true. The model predicted that a dog is not a cat, and it actually isn't. Then there is a false positive combination, otherwise known as type 1 error, which can be interpreted as the model predicted positive, and that's false. From which you can see that the model predicted that a dog is a cat, but it actually isn't. Finally, there is a false negative combination, otherwise known as a type 2 error, which can be interpreted as the model predicted negative, and that's false. The model predicted that a cat is not a cat, but it actually is. A confusion matrix is a foundation for many other metrics used to evaluate the performance of a machine learning model. Let's look at the two popular metrics, recall and precision, that you will encounter in the label. Recall refers to all the positive cases and looks at how many were predicted correctly. This means that recall is equal to the true positives divided by the sum of the true positive and false negatives. Precision refers to all the cases predicted as positive and how many are actually positive. This means that precision is equal to the true positives divided by the sum of the true positives and false positives. Let's use this example to understand recall and precision. Imagine you are fishing with a wide net. Out of the 100 total fish in the lake, you caught 80 of them. In the process, your net also caught 80 rocks, bringing you total hold to 160 items. In these scenarios, our recall is 80%. We get this by taking the 80 fish we caught and dividing it by the total number of fish that were in the lake, which was 100. Our precision of the other hand is 50%. We calculate this by taking the number of fish we caught, 80, and diving it by the total number of items we collected, which was 160 fish and rocks. And let's say you wanted to improve the precision, so you switch to a smaller net. This time you caught 80 fish with 0 rocks. The recall becomes 20%, 20 out of 100 fish collected. And the precision becomes 100%, 20 out of 20 total fish and rocks collected. Now that we have a predicted result, we need a way to evaluate how well our model did. This is where recall and precision come in. First, let's look at the table on the left, which is called a confusion matrix. This helps us visualize our model's performance by breaking down the predicted values versus the actual values. A true positive is when our model correctly predicted a positive case. A true negative is when our model correctly predicted a negative case. A false positive is a mistake where our model predicted something was positive, but it was actually negative. A false negative is a mistake where our model predicted something was negative, but it was actually positive. The definition on the right of the slide shows us how these values are used. Recall refers to all the actual positive cases and looks at how many of them our model correctly found. Precision refers to all the cases that our model predicted as positive and ask how many of those predictions were actually correct. Precision and recall are often a trade-off. Depending on your use case, you might need to optimize for one or the other. Consider a classification model where Gmail separates emails into two categories, spam or not spam. If the goal is to catch as many potential spam emails as possible, Gmail might want to prioritize recall. In contrast, if the goal is to only catch the messages that are definitely spam without blocking other emails, Gmail might want to prioritize precision. We can use the area under curve as an aggregate measure of performance that works across all possible classification thresholds. This is especially helpful when you don't know what decision threshold will ultimately be used for your model. It's like asking a question. If we pick a random positive and a random negative, what's the probability my model scores them in the correct relative order? The great thing about area under curve is that it's both scale invariant and classification threshold invariant. This is why people like to use it. And people also sometimes use area under curve for the precision recall curve, or more recently for precision recall gain curves. We just use different combinations of the four prediction outcomes as metrics. However, treating area under curve only as an aggregate measure can sometimes mask some effects. For example, a small improvement might come from doing a better job of ranking very unlikely negatives as even more unlikely, which is fine but may not be very beneficial to the business. Training machine learning models is an experiment in finding a model that fits your training data without simply memorizing it. As you can see on the far left, we have a simple linear model that is not complex enough to capture the relationship in the data. This is called underfitting. You can tell a model is underfitting if the loss metric is not low enough, as there are many points that fall outside of the trend line. On the other end of the spectrum, on the far right, we have a very complex model that has memorized the training data almost too well. This is called overfitting. This is where your evaluation data set becomes so important you use it to determine if the model is overfitting and won't generalize to new data. Somewhere in the model, somewhere in the middle, as you see in the center graph, is the right level of model complexity. Let's now look at how we can use our evaluation data set to help us know when to stop training to prevent overfitting. Now, once you are doing training, you need to tell your boss how well your model is doing. What data set do you use to do that final evaluation? Can you report the error on the validation data set, even if it's consistent with your training data set? Actually, you can't. The reason why is that you used the validation data set to decide when to stop the training. So it's no longer independent. The solution is to split your data into three parts: a training set, a validation set, and a new, completely isolated silo called a test set. Once your model has been trained and validated, you can then run it once against the independent test data set. That is the loss metric you report. Now, what happens if your model fails to perform against the test data set, even throughout its past validation? It means you cannot retest the same model. You either need to create and train a brand new model or collect more data. It's far better for your model to fail in the final test than to fail after you have put it into production. While this is a good approach, there is one small problem. No one likes to waste data, and the test data is essentially held out and wasted. So, is there a way to use all your data in training and still get a reasonable indication of how well your model will perform? A compromise method to deal with not having a lot of data is called cross-validation. The idea is to do the training and validation split many times. Each time you train your model and then measure its performance on the validation data. Then you swap the data around so the training and validation sets are different. And you repeat the process. After doing this many times, you average all of the results. This gives you a more reliable score and good idea of how well your model will perform. all while getting to use all of your data. The downside is that you have to train your model many more times. So here's the rule of thumb. If you have a lot of data, use a completely independent test set. If you don't have a lot of data, use this cross-validation approach. So how do you actually go about splitting this large data set into these silos? That's the topic for our next lesson on sampling. The core idea here is to find a balance. So far in our training process, we have only been focused on minimizing the loss or error of our model. And now we need to balance that against the model's complexity. The truth is that an overlay simplistic model is useless. We need to find the right balance between simplicity and accurately fitting our training data. Later on, you will see that we can control this balance with the lambda coefficient. This allows us to control how much we emphasize model simplicity. This lambda value is hyperparameter that requires tuning. This is why we say that machine learning requires some artful skills. This approach is more principled than early stopping because it directly penalizes complexity. Regularization is one of the major fields of research within machine learning. Before we dive into the details, let's quickly remind ourselves what problem regularization is solving for us. It refers to any technique that helps a model generalize. A generalized model performs well not just on the training data, but also on never before seen test data. There are many published techniques and more are still being developed. As you can see, we have already mentioned early stopping and the group of methods called parameter norm penalties. There are also methods for dataset augmentation, nose robustness, and many more. In this module, we are going to take a closer look at these regularization methods, which come from the parameter norm penalties group of techniques. So, my congratulations if you are still here. Today we did big job. We dive deeper into main concepts at Machine Learning Foundation. And let's back to our chat. And I'll searching for our another speakers because now I want to move to our simple questions, which can be at exams. So so Kate, I see you. So now I'll give you moderate mode and you can unmute microphone and share your screen later. Now I'm searching for Muhammad. Kate, how are you? As I mentioned at the start of this event, Kate is a Woman Tech Ambassador. Already has this way.
Well, I can share my experience how I did the exam, how I trained. Is it
Yes,
okay?
yes, of course. Hi, how are you?
I'm fine, thank you.
Okay, I'm still searching in attendance list for our another speaker. But meanwhile, you can introduce yourself, tell how it's going on your exams. So anything you want. And at the end, don't worry, I'll share a link at our Discord channel and homework for next week. There will be a list of labs. So, Kat, you're welcome.
Thank you. Well, I was doing this exam online. It was online proctored exam. Um, I the day I landed, my airplane landed and it was late, so I managed to be on time during exam nevertheless, but it added more stress for me. But what I can say, it was good that during this exam I could drink water, and it is allowed also to eat. But I didn't eat, but it was good to drink water because it takes 2 hours. And also it's 50 something questions, more than 50, so you need to be quick to do all the exam questions. Also, you should be alone at the room, and you should have good internet connection. If you don't have good, no, there wasn't any coding problems. Oh, I saw some piece of code, but it was not like you should write something. It was like you should add some line. You should choose from different options a line of code where to put. Yes, 2 hours.
2 hours. And I know that you had experience passing exams online and in person, and how what's the
In
difference? It was
person,
much
it
useful
was
online or in person.
in person was Microsoft Azure exam, but I think it will be the same experience because I saw that this test center, it does also Amazon and Google exams, so it will be the same. So when I was in test center, I arrived a bit early. So they asked me to show my ID, passport, or maybe driving license. Well, when the exam, you can schedule it yourself.
Exactly.
You should select
To
any
you,
date.
Mamita, up to you.
Yes.
Only you decide when will be your exam. We
But I
not.
can tell you that in summertime it will be hard to have a free schedule time because usually they do it in universities, colleges. So I wanted to do other exam on site in Lithuania, but I couldn't set up it because they do it in September only. Because everything there is in colleges, in universities, and they now are just on vacation.
And someone asking
No, I
about
think
what I
the
think
time
that
is the same time as a non-native speaker.
yes, no matter, just 2 hours, no more.
I know that in Microsoft Azure they add maybe, but I haven't heard about Google.
I know two
So
hours.
So on site, they photo you, they give you some paperwork to sign. Then you have to put your bag um, uh, in um, in locked like area, and you don't have to have anything in your pockets. You should show to a person there that you don't have that you have nothing in your pockets. Then when it's time, you go to another room where can be another person doing exam. So you have to prepare that someone can be a bit noisy, like in library, but not a big noise. There will be a piece of paper and a pencil. You can mark your questions, but it's not like you can fully write them just to mark a question. One piece of paper is not not enough, but maybe you can put a mark there. And there will be everything will be on camera, so a person that walks there, he will see everything that you're doing. So
Nice.
yes, the session is recording.
Yes,
So
later I'll share. By the way, I will share a Discord channel. So this is a link to our Discord channel. All necessary links, resources will be placed here. And I think it will be much easy if we forgot mention, discuss anything, please share your questions here. Yes, so we will back to chat later
well,
mm, and
Google exam provider not person view, but I think that on site it will be everything and person view in the same building, but Google exam provider not person. So it would be a like person view experience, but not the same.
I have another question to you because your experience really will be very useful. What will be much useful to prepare for this exam? For example, best resources. Of course, we have list of courses which is good to finish. Google Labs. So, what you find was much working for you? For example, if you study one more time and try to prepare for this exam, uh, what should you concentrate it on more?
Well, I liked skill boost material.
Mhm.
It's very useful, I think. Well, Dan Sullivan's courses on Udemy are good, but it's for money, it's not free. Um, this course is the one that we are doing now is good, so it helped me also. Um, for like the basic information, there is Priyanka Vergadia book, Visualizing Google Cloud, but it's for somebody who is new, completely new in Google Cloud, so it's not like deep.
I think here a lot of attendees new in Google Cloud, and
So
I think.
Priyanka's
And
book is
for
good.
example, Arcada is, for example, now start Arcada. And if you are new in Google Cloud, feel free to play Arcada. You will dive
Yes,
so deeper into Google Cloud platform and resources. It's true. Yes, of course. We will. I'll share all these links. Don't worry. Everything, recorded video,
the
best. put these links I'll share here. And everyone who registered at this event, you will be able to join Skill Boost and Google Cloud, but exactly with the same email you used during registration to visit this event.
About vouchers, there was an action the first half of the year. There were distributed vouchers like 50% off, but this already finished. So I managed to do 50% off, but maybe something will be also can be done. I don't know.
We will discuss this at our last sixth week. So when everyone stay together with us and don't lose motivation and finish all 6 weeks necessary materials. So at the last session, we will discuss everything about voucher possibility of this. Today, no. Today, when we can't discuss this yet, it's too early. Now we just uh, try get motivation to go till the end.
Yeah, but keep an eye on vouchers information because they
Oh,
usually do it like frequently, so you can get it. Maybe not now, but in couple of months there will be some posting where they give away some vouchers. So you just keep an eye on this stuff.
yes, of course. And don't worry, all necessary and very such information I will share in Discord because all the time I will need something to motivate you to go till the end. So of course I will find everything best uh, for this group. And okay, I still can't find another speaker, Mahamat. He will support. He will be speaker at our third week. So next Saturday, uh, Kate will be speaker, and we will dive deeper into all these sessions. So, what I wanted to mention. So here I shared slide with arcade game. Please feel free to scan QR code and open. And later I'll share with you very good group of facilitators which support a lot. Last time when I take part at the arcade game, they supported me, so I get even beach champion. It means that I finished more than 400 laps. Okay, and this skill up, and okay, I understand that it will be helpful. I understand it a lot. So about homework, I'll share with you in Discord channel and will asking you if you don't done yet finish machine learning crash course, intro to artificial intelligence and machine learning, skill boost, feature engineering, and prepare data for machine learning APIs on Google Cloud and machine learning operations, MLOps with Vertex AI. So all this list of courses I'll share with you at Discord channel. So, Kate, do you have what to add from your side, or even good luck? And let's.
Yeah, good luck. And also there is official book for learning from Valley publishing, so you can read it. And of course, it's also not free. And also, there is a book from Pact Publishing also about ML exam, so you can buy
Oh,
it.
I see Muhammad. You are here. Thanks God I find you in the long list of our attendees. So I'm so sorry, Kate. But Kate, if it's possible that you share a list of resources you are sure will be a good fit
Yes, just a
mm,
minute.
in Discord channel, yes. After we finish this session, we will share all this in channel. And Muhammad, hello, how are you? And you are our
Hello.
speaker. Yes.
Hello,
I'm so
Anna.
sorry. I'm so sorry. I searching scrolling because today we have a lot of attendees, a long list of attendees, and I was need to find you to open you to change your mode to moderator that you can unmute microphone. So I wasn't success at first. So
Okay, I'm here now.
yes,
Okay,
and
you may continue.
I introduced you, so Mahamat, you are our speaker, Google developer expert. You already have this certification, already finished these necessary courses, pass this exam, and you will support this group of attendees during next 6 weeks. And from your side, please few words about how it's going, best motivation, where you get motivation to go till the end. You're welcome.
Thank you, Anna. And thank you, Kate, and everyone who is attending on this study series. It is a really great honor to speak here. Actually, this is a very good decision, actually, who want to achieve the machine learning engineering certificate. Okay, I just try to say this is not only one of the decision. This is the great decision. Before I discuss some things, I need to give my introduction basically. And I say I'm Muhammad Al Amin. So I've been working. It's been a long time in the IT sector in the individual field. Basically, first I was in as a played a full stack developer. Then I played the role software engineering, and as well as now as a solution architect. I build the product myself from scratch on different type of field. You can consider as a fintech or property related property management and other use cases, public relation management, HR. I build solution myself. So why actually I choose the certification? It will increase my expertise and why Google Cloud certification and how I came here actually. This is quite a little bit interesting actually. IT going so fast, information technology basically. There is a lot of tools, platforms, and applications are coming. And the lot of resource also in the one line, you can do it. But problem is we are missing something to understand actually what is our problem in our professional lives. Suppose you are working as a software engineer or database engineers, as a solution architect, whatever you can call yourself. Most of the time you have struggle not only for what the tools you know, but you are facing the problem how you utilize best way your understanding on your use case to solve the problem. And this is here Google Cloud certification. Google Cloud certification, especially machine learning certification, will train you to understanding how you can make the decision when you face the challenge, how you can implement Google Cloud platforms, tools, and application in your problem scenario. This is the strong point to get the certification to understanding. And a lot of times when we spend leisure times, you know, so when you attach with one mission, it will inspire you to learn something. Otherwise, you're losing times and concentration. Okay, certification journey will give this opportunity to hold on tight or your mission so that you can fulfill to your professional journey to understand on specific subject on specific topics. I passed machine learning certification as well as I renew twice this machine learning certification, and I'm also holding others Google Cloud Professional and Associate certification as well, such as Solution Architect and a Data Engineer and a Database Engineer, then Security Professional, Networking, Associate Cloud certification, and Digital Leader certification, and the last new one, Associate Data Engineer certification, and GenAI certification as well. Every certification, believe me, there is nothing you can able to write good coding and good programming knowledge is better than how you manage your work, how you cooperate with your team, which the situation, which kind of decision you should take, what kind of tools and what kind of feature you can implement each of these key point on your problem to get the success. To get the success. This is the insight or playing full syllabus of this certification. First time I misunderstood. Believe me, when I first sit on the exam, I was so happy. You can feel something as it is it's a big deal or really hard mission. So some no, this is not like this. You feel one yourself, be easy and be comfortable. This is not it is a very big fight. Not that this is a big fight. Okay, just find out sometimes little bit times from your leisure time that you spend ideally or something. Give the concentration small topic on the Google Cloud machine learning, whatever certification you did. Choose the one small topics. Okay, find out what is this, why you should use, what kind of problem you can solve it, what purpose you can use. You will find out your solution because exam question will come, give you the problem scenario, hint something. Okay, then they give you the multiple choice question and you need to choose one from there. Sometimes you will find out yourself that, oh, 1 2 3 is like all of this is correct or similar question, but no, there is something inside in depth thinking, historical thinking, that will be make different to choose the correct question. Why I'm talking these things? So I hope when my session will come, I will reveal something for you to uh, on how you can success on the machine learning engineering certificate, not only certificate, as well as how you can deep dive in a machine learning professional. Because certificate achievement is a different thing, and professional implementation and playing it's the different things. So you need to yourself to prepare not only for achieve the certification as well as to fulfill your understanding in a professional way. For that reason, you should give the concentration on Google specified machine learning certification guidelines as well as your Google Cloud customer journey and customer history and documentation that will reveal you to find out the special use case, how they problem solved, and why and which tool they are used, you will find out. And it will be very easy for you to understanding and to keep it remember to solution to solve your solution, and you will get the better understanding for this journey. I will try to focus actually how you can deep dives on your machine journey and you feel comfortable to get this answer. So I will meet you when my session will start. I think it is the week 2 or 3, 3 or 5, 3 5, and assign me. I will try to do some my best. Okay, I hope everyone will like it. There is another things I want to share with you. Basically, I did not just only did the professional certification. I did a lot of experiment on the Google Cloud Skill Boost on a different type of event. I did not leave any opportunity because I did not feel no. I need to sit on the study. I need to do study regularly. This is the time frame for me. This is no. Every day I feel this is my today. I need to learn something, just 10 minutes or 15 minutes. Okay, why not we choose these topics? Okay, we to learn something. That this kind of technique, you feel easy. There is no burden on your freedom mind, free mind. We are a lot of younger. We are always feel, oh no, it is a feel boring. Okay, let us do fun. The study is a fun, basically. This is not something you find told you. Oh no, sit down now and complete it now. This is not. You find out yourself very comfortable. Okay, every day just 15 minutes, 10 minutes. Okay, choose the small topics. Small topics. Okay, why not is the machine learning during this study journey? Okay, choose the small topics and find out what is this, how you can use it, why you should use it, what kind of situation you can apply in your use case, and what kind of use case it will reveal you can find out yourself actually where you are. So I hope you will enjoy, and thank you, Anna, to arranging such a great and outstanding event that will help our community who try to learn and who try to achieve the machine learning engineering certification. And thank you, Kate, and other speaker who will join us. Everyone will give you the very good insight, their experience as well. I will try to give my experience as well. And I asking you everyone blessings so that we can success this event. Thank you everyone to joining this event. Thank you for the Anna.
Thank
So,
you.
thank you, and thank you, Kate, and thank you, Mohammad. And Mohammad, yes, next week will be Kate, key speaker, with your support. And
Okay.
week 3, I think 4 and 5 will be your. We will discuss later. Yes, mainly we need to get fun of these 6 weeks. We need to hold motivation, don't lose motivation,
Yes.
go together till the end. So, see you at Discord channel. Let's continue here. I'll share all necessary links, uh, homework, skill boost, code labs, Arcada game. And by the way, Arcada game is already started. So, okay, this session was recorded. I'll share in Discord channel as well. Biggest thanks to everyone for finding time because it's Saturday. I understand. Thanks for our amazing speakers. Biggest thanks for amazing attendees. You are so active, so positive. I hope we will hold this motivation till the end. So, biggest thanks one more time for joining. Yes, I'll send all necessary links, homework, recorded video uh, in Discord channel. Before we finish, I share link to Discord channel one more time. because I share it at the top of this discussion. So before we finish, please open Discord channel link, and we will continue here at general chat. I'll share all necessary. Yes, all necessary links. Okay, Legi, thanks one more time for joining. Hope we will hold our motivation till the end. And see you next Saturday at the same time, at the same place. See you. Bye.